अस्सलाम वालेकुम। उम्मीद है आप सब खैरियत से होंगे। Our today's video is a very important video for fourth semester students or the students who are in their final stage of thesis write-up. So in today's video we will discuss what is basically the meaning of different terminologies in an ANOVA table, and then how we can decide whether a set of data is significant or non-significant, or how we can adjust our available data as per our needs. So let's continue our today's lecture. Some slides are added just for the sake of story building, so that we can easily understand the basic concepts and dig out the core thing needed to understand that concept. So why it is important that we understand what is a significant and non-significant data, and what is the reason that I am making a special separate video on this specific topic. So it helps us to interpret our ANOVA tables, which is the core of your stat application and your research. Those ANOVA tables basically the representative of your data. We can easily interpret them. We can avoid misreporting of our findings in our thesis. Although most of our findings are self-made, but still we have to make sure that we don't misreport them. How funny. Crucial for pairwise mean comparison table presentation. When we move towards our mean tables, we have to do lettering, which actually shows the significance or non-significance of our data. So all these are the reasons why we need to understand the importance or the concept of data significance and non-significance. ANOVA table, as you people already know, we have studied it in statistics course also. It is the result of applying stat on a given set of data, and basically it shows us the source of variance in our given data. The variance comes from different sources like treatment, duration. Then we move towards grouping. In field experiment, we make blocks or split plot. There are so many sources. We just have to study that what variance or variation is coming from what source, and what we can deduce from it, what results we can extract from it to support our hypothesis. So if this recording is about the theoretical knowledge of statistics, I would be explaining all of these entries, but for now I will be discussing only these two entries which are important to us. I have already discussed them in our previous lectures, but I am making this short video and specific for one topic, so that more students can benefit from it, as if they don't have time to go through the previous long videos. So in simple words, if I talk about the f and p value, f value shows how much error is there in your data, and p value shows how significant is your data, or we can say how significantly the data differ from each other. Let's say I take the example of these three values. Consider them as irrelevant to this given table. Just these are three numerical values: 12.4, 13.8 and 26.2. So 12.4 is different from 13.8, but not that much difference as compared to 26.2. There is hell of a difference between 12.4 and 26.2, but there is a little bit difference between 12.4 and 13.6. So If we compare these three values, we will say that the value 1 is significantly, yeah, or we can say highly significantly different from the value 3, but it is just a little bit, or we can say non-significantly different from the value number 2. So this is the whole concept of the significance of your data. We have to compare the mean values, not the replicant values, but the mean values. They have to be significantly different from each other to make sure that your p value remains lower than 0.05. Now, if I talk about f value, uh, it directly depends upon your replicants. The three values you make of every mean value, f value is dependent upon those values. Later on, I will show you a stat file, Excel file, and then I will explain this concept of f value. Let's move towards our next slide, in which there is two-way ANOVA table. This was one-way ANOVA. This is two-way. So here two more sources of variance came. One is temperature and then one is interaction. Like if we are talking about our product or a crop, so first source of variance, let's say, was of uh, our treatment. We are varying the composition of that product, so that is first source of variance. Then we are studying its effect during storage, or we can varying even the product type, or we can just bringing in any other source of variance that will come here. Mostly in FT it is the storage study, and then we discuss the interaction of both of these sources. Like first thing is treatment 1 is 50-50 of two different floors, and then the second source of variance comes when we discuss the composition and the different proximate properties of that specific treatment at 7, 14 or 21 days. Firstly, we were just focusing on the composition, but now we are focusing on the changes that occur in that specific product on 7, 14 and 21 days. So there are now two different sources of variance, and then we discuss their interaction. Most of the time what you will see that our first two sources will be significantly different from each other, but interaction will be not. So it is not a big deal. It is mostly normal uh, if these kind of results came. Later on I will tell you how we can even make this interaction significant if the teacher demands. Otherwise there is no such need, to be very blunt or clear about it. So, F value, how much treatment effects differ relative to error. P value tells whether the difference is statistically significant. I have already explained this term. These are the just pet rules that we need to mention below our ANOVA tables, and also we are continuously discussing in these on daily basis. So I will not spend much time on these. Let's move towards one of our Excel sheets and try to understand the concept of F value. Let's say this is my data. Okay, now see, my mean values are 8.3, 7.4, 7 and 8.25. Let's just consider these four values. If I talk about p value, this data can be regarded as just significant or less significant, because there is not much difference, just of 1 or 0.9 numerical value. I am here to explain the f value to you people. See, these are the three replicants of, sorry, T naught. Mostly what students do, if their mean value is 8.3, they would simply make two replicants as 8.5 and 8.4. Okay, if their other mean value is 7.4, they will make it like 7.5, 7.3. They don't just bother to what I would say, vary the values a little bit, or just do a little bit more effort to make the things look like real. So we don't have, or I would say you people must not do such mistakes. If we make the data like this, 8.4, 8.5 and 8.3, I will not do this by applying the statistics or explain it. I would just tell you, if your data looks like this, your f value will range in thousands. It will be more than 10, 20, 30, 40, 50,000, based upon how accurately you have put the difference of zero point 0.1 in your data. So you must not do so, because it is not the proper way or the actual thing that happens. The purpose of creating these three replicants is to you can say minimize the error, the human error, the execution error, or what kind of error that can come during your research. We have to minimize it. So how can we minimize the error when it is not there? The error must have, should have been there to be minimized, but the data the students make is just free of any error. So firstly, bring in a little bit, or I would say a large amount of error or difference in your replicants, so your data just look like justifiable and just significant, not highly significant, like it just came from Mars and it is the ideal data that is not relevant on Earth. So if your data looks like this, your f value will be skyrocketing. But I am again repeating, just add a little bit of error in your data and your f value will be within the actual limits, that is from 0 to, you can say, hundreds, 400, 500, maximum 1000. More than it shows your data is highly significant, or simply there is not much error in your data, like you completely you are trained about performing those analyses, and the environmental conditions were perfect, your equipment was working perfectly, and you didn't even miss a single second in doing your experiment, that everything just was perfect. So we know, everyone knows that that is not the case. So make your data accordingly. Next, I have explained the purpose of p-value. It shows the significance of your data. F-value, where does the error come from and how we can adjust it. Now the last thing, the lettering we do in our data based upon the mean values. A, AB and B. This shows that A is significantly different from T1. Now I will again need you people to keep these values in mind. A means, let's put 8.5 here. So one value is 8.0, then 8.9. Let's put 7.9 here. 8.1, 7.6. So 8.1 is relevant to 8.0. it if we round it off, it will be 8.1. So this AB means some of the means or some of the replicants in these two datas are similar to each other. If we add 7.1 here, it will be very evident that there is no value similar in both of these as of T2. So that's why it carries the letter B, that it is not as much relevant to the upper values, or we can simply say the T3. The similar letters that are coming just explains that the value 1 above or below that value, the means are somehow correlated, and if the means are totally different, sorry, letters are totally different, that shows that the means are significantly different from each other. Here we know this is the data of sensory evaluation, and in that there is not much difference in our values. That's why the lettering came out to be A, B, and B. This is the ideal situation if the data of your research is not non-significant. Basic thing that I have explained in many of my previous videos is that the purpose of your research is just not to come up with significant results. It is to analyze, perform experiment, and come up with results for your specific hypothesis. Whether the method you are applying to resolve a scientific problem is doable, is enough to solve that specific problem, or is it not. But mostly what we do is we try to bring out significant results from every kind of situation, whether they are justifiable or not, they are doable or not, or whatever else. So we can simply ignore this slide while being in Pakistan. So this was all about the significant and non-significant data, how you can manipulate the Excel data to bring down the F value and make your data significant. If you want to reduce the p value, you have to make sure that your means are different from each other. If you want to bring down this to make it look like significant or highly significant data, you need to add error in your replicant values and your data will be good to go. Thank you so much for watching this. Keep supporting. Allah Hafiz.